This question asks us to provide an alkene starting material that will provide this ketone in a two-step process where one of those steps is a pinnacle rearrangement. That's an important point because it tells us that the immediate precursor will need to be a diol. Now, there's two possible diols we might consider that could form this ketone after a pinnacle rearrangement. One of them would have an alcohol here and an alcohol here, and the other one would have the alcohol on the other side of the ketone. So we could have an alcohol here and here. These two possible diols could potentially undergo a pinnacle rearrangement, perhaps to form this ketone. Let's take a look and decide which one is going to be the correct one. If we look at this bottom example, the secondary alcohol will be the one that gets protonated and leaves to form the most stable carbocation. After rearrangement, though, this oxygen will be the one that forms the carbonyl, and we would end up with an aldehyde product instead of the ketone. This is not the correct diol. Whereas if we look at this example, the most stable carbocation would be at the position next to the benzene ring so that the carbocation could be stabilized by resonance. So acid would protonate this alcohol to form a carbocation, hydride shift, and we would get a ketone at the position on the right. So this is the correct diol that we need. When we treat this with H2SO4, we would get the pinnacle rearrangement, not this one. That tells us then which alkene we need. The alkene we need would have the alkene at the position that we need the two alcohols, and that would be at this position. Then we would do dihydroxylation, osmium tetroxide, and sodium bisulfite. Dihydroxylation would turn the alkene into the diol, and then acid catalyst would do the pinnacle rearrangement to form this ketone. This alkene is the one we need to form this ketone through a pinnacle two-step process.